DC motors. Okay. So now we know the construction of DC motor. What are the parts in the construction of DC motor? Yoke from the outer mass. Yoke or frame. Then one after another. So that you can write it easily. The next to the yoke, what it is? Shoes, field winding. What will you call it? Okay, next outer, next there inside. Armature winding. That's armature conductor also. Okay. Next that inside. Commutator. Next that inside. What it is? Resistor. Next what is there in the center part? Shaft. Okay. So describe it neatly. Okay. Describe it neatly. And then what we have seen the working principle. You know what is the functions of each component that is in the construction of a DC motor as well as in construction wise for a DC machine it is similar for both DC motor as well as DC generator. Likewise, the types of DC machines it is both similar for DC generator as well as DC motors. Okay, so if it has been asked is types of DC machine also, or else if it has been asked like types of DC motor, the thing is same. Okay, so types of DC machine. What we are going to see? Types of DC motor. First, DC machine is calculated to what? Classified as what? First, DC. As it is maybe DC generator. What is the principle for generator? Converts what energy to what? Mechanical energy. Since it is a DC, it will convert mechanical energy to DC. Okay, DC, electric. Okay, and what is the function for DC motor here? So if you are giving DC as an input, it will generate mechanical energy. Okay, so first DC machine is classified into two. One is DC generator as well as DC motor. Further, the types of classification for DC generator and DC motor is same. Okay, so if DC motor is generated into, classified as two. One it is, we can say that is self-excited. Or we can say it is self-excited and here separately excited. The same thing for DC generator also. Okay, so DC motor is classified into two. One it is what? Self-excited. Another one is separately excited. The same for what? DC generator also. Okay, so the self-excited motor is further classified into three types. One it is series motor. So, in the construction in the video itself, I have told you the classifications of series motor, how the path connection will be, and how for the shunt connection. Likewise, self-excited is classified into three. One is series, another is shunt, and one more type is compound. Okay, one more type is compound motor. Okay, the self-excited motor is further classified into what? Three types. One is series motor, the other is shunt, and one more is compound motor. The compound motor is further classified into two. One it is long shunt compound motor. Other one is short shunt. Note it down. Long shunt compound motor, or else short shunt compound motor. One is long shunt and other one is short shunt compound motor. Okay, the same classification is for what also? Generator also. There will be specifying it as motor over there. Here it is generator. Okay, so that is we can say that DC generator is classified into two. One is self-excited generator, other is separately excited generator. In self-excited generator has been further classified into three. Series generator, shunt generator, as well as compound. Compound generator is further classified into two. One is a long shunt generator, other is short shunt generator. Similarly, as like the construction. It is same as construction for DC generator and motor. Likewise, types of the motors also, machines also same. Okay, so now in all the construction of series motor, shunt motor, and all that, how will we have seen? We have seen that based on what we are mentioning it as it is a series motor, it is a shunt motor. How we are doing that? By the connections of what? By the connections of the armature to the field. If the armature and field, if it is connected in series, means the motor is series motor. If it is connected in parallel, means it is shunt motor. And construction wise, you know that. Okay, so you have to draw the diagram for it. Okay, put on the heading as DC shunt motor. After writing this classification chart, put up the heading as DC shunt motor. DC shunt motor, how it will be? The armature winding and the field both are in the parallel state. That is right. Here is our motors armature winding, and here is a field winding which is connected parallel to it. So here is a resistance, and then we will be saying it as resistance in shunt or SH. And in armature there will be a resistance inbuilt, that is R suffix A, since it is an armature resistance. Okay. So here the current over here is I suffix S, it is a shunt current, and the current over here is armature current, that is I suffix A over here. Okay. And now this is our motor. And what in case of DC motor, what is happening here? One is due to the operation, like I told you during the working principle. One is by giving the direct current, mechanical energy generating. That is one thing going on inside. Other one principle is going inside. What it is? EMF principle is going inside. Okay, that is a current carrying, and the magnet. The armature winding is in what? In between the two pole magnets. Okay, so what is happening here? There is an EMF being induced. Okay, so you have to mark that also. That is EB. Okay, that is a back EMF is also being generated. That is said to be EB. Okay, E suffix B. Okay, and after this, what it is here? Since it is a DC supply, we will be marking it as plus minus DC supply. As I already told you, if it is DC, you have to mark it as plus minus DC supply, and you know what to do for a AC supply also. Okay, so this is the diagram for a DC shunt motor. You don't need to describe it in detail. Just you have to draw the circuit. Two lines you have to explain. What is that? That field winding is connected how? Field winding is connected in parallel to the armature winding. Now you can say that field winding connected in shunt manner to the armature. And next what we have said, the resistance which built in the shunt field winding is what? RSH. And the resistance built in armature is what? RA. What is the current that is flowing through the field winding? That is ISH. And the current that is flowing through the armature is I suffix A. I am asking current, so it is I suffix A. Okay. So just you have to describe that. Okay. And next, draw this. And next, put on the heading as DC series motor. So you all know that in DC series motor, how the field winding will be in series to the armature. Okay, so we have connected that field winding in series to the armature. Okay, so DC supply is given to the given as a input over here, and it is our field winding, and here it is series, right? So the resistance we have to mention it as series, SE. Okay, RSE. In shunt we will be mentioning it as RSH. Okay, and for as well as here for the resistance, it is armature winding. So R suffix A. What is being generated here? Back EMF EB, and this is our motor over here. And here the current is the total current, which is I. The current which is passing through this RSC will flow to the armature also. So we can say that as what? Current in series, the flowing through the field winding is I suffix SC. Okay, and likewise for the armature it will be IA. Okay, and here what will be the current? Will be like all the three currents are equal, right? Since the flow, that is I is equal to ISC What is here? IA. Okay, armature. Okay. So, one thing we have to note it in this series motor. Okay, series motor cannot be started at the no load condition. Okay, if there is no any load, it cannot be started. What is the reason means? The starting torque is very high. Okay, you want to know a relation for that. That is the speed of the motor N. The speed of the motor N will be proportional to voltage they are applying divided by flux that is generating. Fine. Okay. What do you know? The relation between the speed and the flux is what? Phi. This is how it is. This relation between speed and phi is how it is? Inversely proportional. So what happens if flux is very low? What will be the speed? Increase. It will be high. Okay. So if flux that is at the no load condition, when it is I am saying at the no load condition, there is no load in the motor. Okay. While you are starting the motor, if there is no load means what happening means the flux is very small. Okay, now we can say that the current is very small over there. Okay, so the torque is entirely high. The starting torque will be high for the series motor. So because of that, at no load condition, the speed of the motor will be drastically increased. What is the reason? At the starting position, the flux is very small at the condition of no load. Okay. It is the flux is very small, or we can say that current is very small. What is happening? The speed. The torque is high. Because we can say that initially we are having a high starting torque, and so that the speed of the motor is drastically high. Okay. If we have started that DC series motor under no load means what happens means the starting torque is very high. Speed of the motor is drastically large. Okay. What happens? The machine may get damage, or if suppose what may also happen, accident may also happen in the workplace. Okay, so we should not start a DC series motor in no load condition. Okay, and you know that what is the we have already seen what is the speed at capacitor resistance motor. Initially it is how very high. After that, when the load is getting low, what is happening? It is we have seen this graph, right, in the during the working principle. Okay. You just keep these points alone in the mind. What are happening at the no load condition? What is happening? Flux phi is very small, or else we can say the current is very small, and what is high? Starting torque is very high, so that speed is drastically increased. So we should not start a DC series motor at the no load condition. If we started a series motor at no load condition, what is happening? The machine may get damaged, or else accidents may happen at the workplace. That you want to know of the series motor. Okay, and note it down. And the next is compound motor. So next type is compound motor. Okay, compound type is further classified into what? Long shunt and short shunt. Okay, so in long shunt compound motor, here it is what? Field winding, which is connected in series. Okay, so the series combinations of field and armature, we can say that, right? So this exactly the same for everything. And this is acting of EV, and this is a motor with the resistance, armature resistance RA, and a series resistance which RSC, and the current is flowing through ISC as well as IA over the armature winding. These things is similar for this. What is the conception of this? This is a series motor. Okay. In long shunt compound motor, what will come is we will be connecting a shunt field winding. We will be connecting a shunt field winding, which means we will be connecting a field winding in parallel to a combination of series connected field winding and armature winding. What is this combination? This is series. We can say that the combination of seriously connected field winding and armature winding. Already there is a field winding and armature winding which is connected in series. Along with what we are doing? Along with that we are connecting a parallel shunt winding over there. Shunt field winding. This is what? Long shunt compound motor. Okay. So what is the current that being flows here? ISH. What is the resistance that is across here? It is RSH. Okay. So this is also what? Field winding only, but we have to write it like this. Okay. Okay, in a series combination, so the field winding and the armature winding, they are parallel connected. Shunt fielding winding is connected. That is what long shunt compound motor. Okay, just you have to draw the diagram and you have to mention that in terms of words. Okay, and likewise for the short shunt compound motor. We can also write it down. That is the series combinations of field winding and armature winding. The parallel connected shunt winding is connected. That is the what long shunt compound motor. In wordings also, after drawing the diagram, you can write it down. Next one is short shunt compound motor. Short shunt compound motor. The same, but one thing will differ. Okay, now what is this? The series connected and field connected. Okay, this is one pair. You can say it as RSC. The current which is flowing here it is I, and here it is plus minus. We have marked everything for the same here. Plus minus. That is DC supply. You should not miss it. Okay. For each and every circuit, we will be marking the terminals also. DC supply, and here the polarity is minus, and this is our motor with the armature resistance RA, and the back EMF is EB, and here the current is in series of IAC, and here the current is IA. Everything you have to do for each and every circuit. Okay. And now, in short shunt motor, what you have to notice means that this is also what series combinations of a field winding as well as the armature winding. Along with what you are going to do, you are going to connect the field winding just parallel to here. Oh, or else what we can say? Or else what we can say? We can listen carefully how to define this means. Listen carefully how to define this means. First you have to define this. That is how it is connected. Shunt connected. Okay. A parallel connected. Okay. Parallel connected. The field winding and armature winding is connected in series to series field winding. No. Listen carefully. Parallel connected, the field winding and armature winding is connected in series to a field winding. How to define this short shunt compound motor? The parallel connected or a shunt connected armature and field winding or a shunt connected motor. You can say this what? That is a shunt motor, right? A shunt connected motor or a parallel connected motor, parallel connected field winding as an armature winding connected in series to a field winding. That is what short shunt compound motor. For in a long shunt compound motor, with reference to this, you can define this. Okay. In short shunt, with reference to this is parallel. So with reference to this parallel, you are connected in series. In long shunt, with reference to the series, you are connected in parallel. That is how you will be defining the two. Am I confusing you or you are clear? Yes. Okay. Draw this. Just if you want to make it clearly, just make a dotted circle over there like this. Okay, so you can define it clearly. DC motor. After drawing this long shunt and short shunt compound motor, now you are clear with the classifications of DC motor, right? Classification of DC motor. DC machine, how it is being classified? DC machine is classified into DC generator, DC motor, DC generator as well as DC motor. Along that, what you are describing? DC motor. Okay, so DC motor, how it is classified? You can draw the chart for DC motor. You need to go for DC generator. The question will be like this. These types of DC motor. Okay, so in DC motor, further classified into two. One is self-excited, other is separately excited. Self-excited is further classified into series, shunt, compound. The compound motor is further classified into short. Now we are clear with the classification along with the diagram for each. cases. Okay. And next is application of DC motor. In application of DC motor, first this is DC shunt motor. DC shunt motor that has been applied with lathe machine. Okay. You have been noted in this seeing the lathe machine. Okay. So there are where what machine is meant? It is DC shunt motor. Lathe machine, then printing machine, milling machine, and all that are DC shunt motor. Okay. And DC series motor. Can you imagine and tell me what motor will not run when there is no load? When you are going for a shopping mall or somewhere else, a machine will only elevator. Okay, so it is a DC series motor. When people load will be given, then the motor has to be started. Okay, so wherever the load has to be given first, then the machine to be started is what? DC series motor application. Okay, that is like elevator. We can say that cranes. Okay, we can say that traction motor and the like on what? Trolley cars. Have you noticed that? Trolley cars or trolley buses. Okay, all that we have what machines is applied? DC series motors is applied. Traction motor, cranes, trolley cars, trolley bus. Write it down. If you wanted to note it. Application of DC shunt motor. Application of DC shunt motor. Lathe machine, milling machine, in mills, in rice mills for grinding something. Okay, printing machines. Then for drilling machine, have you seen right? Drilling machine. All that DC machines are DC shunt motors are applied. Okay, lathe, drilling, milling, printing. Okay, then DC series motor. DC series motor has applied in traction,